I am still on page 202, but we're talking about end behavior on these graphs. So let me just, we're going to do 5 examples. So let me make a coordinate plane. I think I'll do a 3 by 3 again. Well, that's a little bit more. Let me erase just a hair on that one. And I'll copy this so you don't have to watch me do that again. Okay, so before I even do a graph, let's talk about what end behavior means. So the definition of end behavior, it describes a graph as it extends in either direction away from 0. And that's the definition. So let me show you some examples that should help. So let's consider this graph. We're going to put a positive slope. I'm going to put it right through the origin because I seem to have better luck doing that. So let's draw a line right here, just like so. Now we already know that that is a positive slope. What you want to do is look at the ends of your arrows, where the arrows are. This particular end is extending upward to positive infinity. In other words, if I could just keep drawing forever and ever, the line would never stop. And then this end extends downward to negative infinity. So this is nothing scary. It's just talking about what's happening on the ends of your graph. So let's try another one. This time I want a negative slope passing through origin. So I'll use a different color just to keep them straight. And here it comes. Whoa, that's not good. Down through the origin. Okay? Or close to the origin. But it's not the intercept this time that I'm interested in. It's the end behavior. What is that graph doing on the ends? Well, this is extending upward, and in terms of y, it's positive infinity, but in terms of the x value, it's negative infinity. That's what's giving it its negative slope. So I'm just going to say that it's extending upward. And then on the right side, it's extending downward. Again, on the x-axis, it's extending to positive infinity, but on the y, it's extending to negative infinity. So we'll just leave it there. The end behavior is different for those ends. Okay, here's another example. You'll like this one, or I like this one. Let me change color, and bear with me. I'm going to have to get it drawn, and then I'll adjust it. So this is a parabola. I really don't even have to adjust it. I could leave it right there. So let's look at the end behavior. What's happening to the ends of this graph? This time we could say that it's bilateral, which means that it's both sides extending upward. In other words, it's pointing up on both sides. All right, let's try another one. What if we have, let me make sure I'm not leaving myself out of space. Let's put it right up here so I have room. Tell me about this end behavior. I need another color. Let me use green on this one. Let me get that axis lined up. This one. Oops. It's 1 in the morning, guys. Can you tell? Okay. The end behavior on this one. What's happening there? How would you describe that end behavior? It's bilateral. It's the same on both sides. So it's bilateral extension downward. Okay. All right, let's look at one more. How would you describe the end behavior on this fellow? I need another color that I haven't used. I guess I'll have to use pink. And let me zoom in here so I can do my best to draw it. What's happening on this end behavior? Well, down here, this is not bilateral because different things are happening. Down here, we could say that this end is approaching the x-axis, but it doesn't touch it, so we can't say that it intersects the x-axis. We could say that it's approaching the x-axis. And this one, we could say that it's approaching the y-axis. But it's not touching it. It's not bisecting it. It's not crossing it. It's just approaching it. Okay. So those are some different examples of end behavior. Again, don't make it complicated. Just common sense, logical discussion of what's happening on the ends of those graphs.